Hey, I'm Kirk Harnack. On This Week in Radio Tech, Tom Ray and Chris Tobin are here. We're talking about nanotechnology, tiny little capacitors, skin effect, woohoo, and bees in the feed horn. That's coming up next on This Week in Radio Tech.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for This Week in Radio Tech is brought to you by Cachefly at CACHEFLY.com.
This is This Week in Radio Tech, episode 134, recorded June 20th, 2012. Bees in the feed horn. This Week in Radio Tech is sponsored by the Telos Alliance. Check out the catalog, the blog, and plenty more on the website at telosalliance.com. Hey, it's time for This Week in Radio Tech. I'm Kirk Harnack, your host. Glad you're with us. You have tuned in to the podcast, the netcast, the webcast, where we talk about radio technology. That's just not only traditional radio, although that's a big part of it, but we also talk about audio technology, RF technology, as it affects cell phones and Wi-Fi and all kinds of other services. And lucky for me, I've got a couple of real experts along with me to help me out and set me straight and correct me when I'm wrong. Let's check in with, first of all, the best-dressed engineer in radio from Manhattan, New York. Here he is, Chris Tobin. Hi, Chris.
Hello, Kirk. Hello, everyone. I hope all is well here in the East Coast, New York City. We're experiencing a heat wave. So those of you who may be watching the news or weather, it was close to 92 degrees today, real field temperature of approximately 104 degrees. Woo! And the humidity, for those of you who keep track, was close to 70%. So, yes, it was a wet blanket today. So even in the shade, it was not cool.
It's like Nashville every day. Welcome.
Exactly. So, but I received a lot of calls from folks today asking about the weather. I was like, okay, fine. I'll make sure I make a note to say it. I'm not sure why, but that's what I got. But yes, so along with that, I attended a trade show today for those of us in the business. So that's why I'm wearing a shirt and tie for those watching the video. For those of you listening, I'll just rub the cloth together so you can hear it. There you go.
What kind of trade show, pray tell?
DV Expo East, Digital Video Expo East. So we're showing off some video codecs today.
That's very cool. I want to know more about those someday. Maybe we'll devote one of our future shows to talking about video codecs. Since so much of radio involves video nowadays, at least for a lot of forward-looking stations. I know when you were at CBS, you guys produced a bunch of video at your radio stations.
Yes, close to 12 hours worth of video each day. And believe it or not, it was more live video from our radio stations than from the local television stations in town.
Oh, my goodness.
Yeah, it was great. So it was good stuff.
Let's write that down for a future topic. How about video stuff that radio engineers need to know?
Sure.
Yeah, that'd be good because I'd be really interested in that. All righty, let's check in with upstate New York there, or not really upstate, but at least the Hudson Valley. Takes him a while to get there. He got there just in time. It's Tom Ray. Hey, Tom.
Hello. Bite your tongue. Everybody says anything north of Westchester County is upstate New York. No, it's not. We're a suburb of New York over here. We're only 50 miles out of town. And, so I'm up here in the Hudson Valley. It's a wonderful place. And I'm a VP Corporate Director of Engineering of Buckley Broadcasting, WOR in New York City, and actually transmitter in Rutherford, New Jersey, and studios downtown New York. And here I am. Yay.
Hey, by the way, I want to give a little public congratulations to someone very important to you. I believe your daughter has won some accolades.
Yes, my daughter, weather permitting, will be graduating on Friday night from Washingtonville High School. She's a senior. She'll be graduating with a 4.0. She, I believe, is 18th or 20th in a class of almost 500. She has won, let's see, she's going to be, in the fall, she'll be going to SUNY Canton, that's State University of New York in Canton, New York, which if you don't know where Canton, New York is, look on a map, find Syracuse, and go about an hour and a half northeast, maybe 2 hours northeast. You hold out your right hand like this, you go, hey, and a Molson appears, because Canada literally is over there. I mean, we're 10 minutes from the Canadian border, but no, she's won the President's Scholarship from SUNY Canton. They only give 2 a year, and it's good for 4 years. She has won a private scholarship from SUNY Canton, and the other night she won the Lions Club scholarship here in New Windsor. So I'm very proud of my little girl. And hey, after she gets her vet tech degree, which is a 4-year degree, she's planning on hopefully going on to veterinary school. So we may have a doctor in the family.
Two scholarships. What will you do with all the extra
three
money?
scholarships.
Well, 3. What will you do with all the extra money?
Yeah, right. Actually, it's a state college, and it's not. The money's actually not that bad. They have some very interesting things up at this school. They've got one of the dorms, because they have a veterinary, actually a vet tech school. They have a dorm that takes pets. So they have a pet dorm. They have a new dorm up there that's more like an apartment building. And they actually offer 2 very interesting course offerings at this campus. One is they have a School of Forensic Science, which a lot of the cops go to, and there's nothing like driving onto the campus the first time and seeing a sign that says, "Please ignore the crime scenes."
Oh my goodness.
Final exams in progress. Police tape all over the place. It was extremely funny.
Hilarious.
And then the other one, they have a school of they offer a 4-year degree in mortuary science.
Sure. Okay.
How to be an undertaker. And they had a career fair when we went up there at one point, and I felt sorry for this poor guy from the mortuary school. He was the only one standing at this table. I went over and talked to him for 45 minutes.
All the rest were laying flat.
There you go.
You got to learn somewhere, and boy, back when I was on the air in radio, it was a little piece of known trivia that country singer John Conley, before he became famous in singing country music and had that hit "Rose-Colored Glasses" back in the early '80s, and some others, he was a disc jockey at WVLK in Lexington, Kentucky, and before that, he was a mortician.
Well, there's a engineer here in New York City. I'll have to tell you who he is offline. That when he was in college, was the midnight guy at the local funeral home. And anyway, a couple of us have started calling him the what the heck are we calling him? The midnight embalmer.
Actually, the name, the Undertaker, would be a great name for an overnight disc jockey.
Oh, you bet. The graveyard shift.
Yeah. I hadn't even thought of that. Of course. Hey, let's jump into some radio engineering. First, I should mention our program is sponsored by my employer, and I thank them dearly for sponsoring each and every one of these episodes for the past year and a half or so, and that's Telos and the Telos Alliance, which consists of 4 great companies all under one roof. Telos Systems, a company of which I'm the VP of Products, also Omnia Audio, Axia Audio, the consoles and live wire people, and Linear Acoustic, a company that makes audio processors for multi-channel and stereo television. So check them out, and we'll tell you a bit more about them during our break. Let us jump into the news and some topical topics. Unless something else comes up that we take off on, our big topic for the show is going to be summertime engineering and what we do to get ready, be prepared, or be unprepared for what happens in summertime for engineering. But we've got a few other stories to talk about, and one of those things I want to talk about, I think Burke may have a graphic here that's maybe about ready for us to look at. It's about the subject of RF and how RF travels through wires. And there's an article in Radio World Online, it's at radioworld.com, by Charles S. Fitch, who's a PE, professional engineer. And this article reminds us about the skin effect of when RF travels through wires. I always think it's a great thing to go revisit some of the basic things about electricity and electronics to kind of keep us mindful of the way things behave. And this idea of skin effect at RF frequencies is important to understand whenever you're dealing with RF circuits. They're different than audio circuits and different than DC circuits because of the way that the signal, the radio frequency or RF signal, behaves as it flows through a conductor. Burke, I don't know if you can bring this up, but there's a little red circle diagram that shows a representation of a cross-section of a piece of wire. There we go. And there's a symbol there. I don't know how to pronounce this. It's the lowercase Greek letter delta. Maybe somebody, Chris or Tom, do you know how to pronounce that? The name of that symbol? Is it just called delta, or is there some other name for it?
Delta? No. That's toga. Oh no.
Okay, so the chat, Dale and Wenko in the chat room say it's just called delta, just like the uppercase delta that we're more used to seeing. So, delta is the symbol it's typically given for this. And Burke, if you want to scroll down and zoom in a bit, there's some mathematical functions there that help us describe just what this area of delta is. The notion here is that 63% of all the AC current flows near the wire surface to a depth which we call this delta. The AC current density, which is represented by J in a conductor, it decreases exponentially from the value at the surface according to the depth D from the surface. So I'm not asking you to remember all this. I just want to point out that this exists. And some examples are given. The skin depth at various frequencies in micrometers. Now, I don't know exactly how big a micrometer is, but it's not much. For example, at 60 hertz, okay, AC current frequency, the skin depth is 8,470 micrometers. I don't really know how deep that is, but it's a lot more than at higher frequencies. Let's say at 1 megahertz, AM radio frequencies. Then we're talking about a skin depth of just 66 micrometers. So this means that 63% of all the RF that flows in a conductor, if that RF is 1 megahertz or around the AM frequency band, it's flowing through the top or the outer 66 micrometers of that copper. Well, that kind of tells you why we tend to use big, fat, thick conductors or conductors that have a lot of skin area, like a flat conductor. Then if you go up higher in frequency, like FM frequencies, 100 megahertz, that area, then we're only talking 6 micrometers is where 63% of all the AC current flows in a conductor. So, okay, so I've kind of set this up. Tom and Chris, from a practical point of view, what does skin effect what implications do we have with skin effect when you're working with RF? Chris Tobin, why don't we start with you? You've worked with both AM and FM, not that Tom hasn't, but talk to us about skin effect and how it affects what we do in engineering.
Well, skin effect in tuned RF circuits would, if you're not careful, actually detune your circuits. It can detune it in a good way or it can detune it in a bad way. So let's say for AM signals, since we're talking skin effect and the surface of the copper tubing that's used in the tuning houses and also in, say, the phaser cabinets for directional arrays, the skin effect there, if you're not careful, if you have two conductors too close to each other, not only do you have the inductive currents throughout the coil, but the skin effect adds to it. Again, these are things you come to learn. There are formulas, as we just spoke of, but after a while, you realize how to watch out for this. In FM, the skin effect is a little less apparent, but it's there. Also, that can say in tuned circuits and say in exciter cables, cables that have that are crossing each other, there's some skin effect there. Higher frequencies, say in the microwave ranges, say 2 gigahertz or 5 gigahertz, 13, 11 gigahertz. The skin effect there is literally just like on the top. So it's that you can detune a circuit by closing the cover of a radio chassis. You can detune a circuit, as simple as that.
Charles Fitch in the article here addresses some of these really high frequencies, like he mentions 11 and 13 gigahertz. At these kind of frequencies, skin effect is just the top few angstroms, he points out.
Right, right.
Which is 10 to the minus 10th of a meter. And he points out that at these frequencies, that's why gold is so often used. Gold plating is used in these circuits because gold is just an amazing conductor, and it can be very thin and take care of all the current needs in a really high frequency application.
Well, if you've ever worked on microwave receivers or transmitters, you will have come across gold connectors. You would have come across pin diodes with gold tips on them. It would be ceramic on one side and gold on the other. That's where you would find it. You definitely would see it there. And the skin effect literally is everything. I mean, I have worked on some circuits where, changing a surface mount resistor, it looks like a little square black dot. And because there was just a little too much solder on the edges, didn't flow it properly, it changed the circuit characteristics. I mean, it was something simple as that. Bypass capacitors that are in the chassis to take the electrical current from the outside of the box, outside the chassis, bring it inside the sealed RF tight container. Even that, at microwave frequencies, you have to be very, very careful about how you tighten the screws, the locking screws, how well you've connected the wire, everything. I mean, even inside, maybe 2 inches of a wire may be too long, and you may have to make it 1.5 inches in order to keep the circuit from being detuned or resonating or changing characteristics, as pointed out in what do you call it, Charles' article. So yeah, it can be considered black art, but you practice, you learn, you start to see the telltale signs of what you've done right or wrong.
So Tom, I understand you were at the transmitter site WOR this afternoon, isn't that right?
Yes, sir.
And so how does skin effect? How does skin effect affect your practice at a transmitter site where, at least with AM, you're talking about 66 micrometers at a megahertz? I guess this means that a lot of copper tubing is used, not solid copper.
Well, copper tubing, but like with the copper strap, it actually makes it very interesting to have a discussion with the electrical inspector when you're building a site, because they walk in and they see this copper strap all over the place, and they say, well, "But you got to ground it." Well, yeah, this is RF ground. Yes, it's grounded. Well, no, it's not. That's not thick enough. Well, yeah, it is for what we're dealing with.
This is true.
Yeah. Well, at the WR site, built the electrical inspector for Rutherford actually had done his homework, because I also didn't have to explain why the towers weren't grounded. He understood. He got it. He had done some reading. But
okay.
No, what's interesting, not only with AM but with FM, and especially with FM, you're running a transmission line up a tower, and that transmission line, let's face it, if you're talking 20 kilowatts of RF going up the pipe, you've got a 3-inch transmission line going up that tower. And if that center conductor were solid, that'd be an awful heavy line going 300 feet up the tower. We're able to use copper tubing as the center conductor, and we fill it with air for a dielectric. There's also foam coax, but we tend to fill it with air. That makes it even lighter. And you don't have as much downward weight on the tower and as much wind resistance, to pull when the wind hits that transmission line. So it's advantageous to us in some ways, but boy, much like with an AC circuit, if you don't sock a lug down really good, like in a circuit breaker box, if you have a loose connector in the center conductor of the coax, that thing not only will burn up, it'll just melt. And actually, I'll take a look here in a minute when Burke switches off me. I may have a piece of transmission line here where it actually threw a lightning bolt and blew a hole right through the thing.
Hey, speaking of coax, in the chat room they're asking, well, we've heard of using nitrogen in a coax. You mentioned an air-filled coax. I wanted to point out that we use air during the day and we use nitrogen at night in the coax.
Well, I never heard that one before, but I mean, nitrogen, air, it's dry air.
Actually, one reason that nitrogen is used is because you can get it supplied to you, and it's dry. You can get bottled dry nitrogen, so it doesn't have any atmospheric moisture in it. Also, nitrogen slightly increases the I'm not sure if there's a word that includes dielectric with that, but it increases the flashover voltage over air, especially over moist air that might go into a transmission line. Now, you can pump dry air. There's dehydrators out there that dehydrate air and will put dry air into a transmission line. So that's another option too.
And unfortunately, I can't find my burnt piece of transmission line. I know I have it. I just can't find it.
Well, I was going to ask Chris while you were looking around there, Tom. Chris, tell us what you know about the difference between using a nitrogen gas versus dry air in a transmission line.
Well, as you pointed out, yes, the flashover point is lowered with the nitrogen. However, if you have designed your system properly and you're modulating the transmitter correctly, you should be able to use the dry air with a dehydrator just as well. Nitrogen, though, would give you a little extra breathing room if you were in a situation where maybe your cable length, transmission, gain of the system requires you to run a little bit closer to the flash point of a coax, which hopefully you're not. A lot of folks over the years moved away from nitrogen, not because of the properties it offers, but the fear of the tank, nitrogen tank at your transmitter site running out because of maybe a potential leak in your system. Whereas with a dehydrator, dehydrator will continue pumping, has a pressure alarm to alert you that, hey, it's cycling beyond the normal pressure points on the system. So if you have, say, 6 pounds of pressure in your transmission line, all of a sudden there's a sudden leak, say from lightning strike, maybe a cable harness connector, a holder on the tower is slipped and is sliced into the coax line itself, so it's sprung a leak. The pressure is going to drop, and the dehydrator is going to kick in and try to bring the pressure back to, say, 6 pounds or 3, whatever your system is. On the equipment, the dehydrator has the ability to alert somebody, hey, I am cycling beyond the normal duty, something's up. Nitrogen tanks, you can do the same thing. You can have a pressure gauge, and yes, you can tell you the pressure is dropping. However, you have a finite source. So at least with the dehydrator, you continue pushing out the air through that hole. Contaminants will not come in, so I believe that's called a positive pressure. So you don't have any contamination getting back into your transmission line, which causes even more issues. So that's why you'll probably hear a lot of folks talk about dehydrators in many applications. Now, high-powered systems where, television stuff, you may not have the luxury of doing compressed air because you do need a little more of the size of the transmission. So there they may do nitrogen tanks, but they have many systems, ways of making sure they never run out of the pressure, keep the pressure intact. Because once you lose the pressure in the transmission line, moisture builds up, and then it's just trouble from there on in.
You ever heard of people using any other gases like nitrous oxide?
No, but I have heard of people using denatured alcohol to clean antenna systems, which was very scary. But
really, why is that scary? Because it can blow up?
Well, let's see. It's denatured alcohol. It's flammable, and you're spraying it onto an antenna array, and they were doing it while it was still transmitting.
Oh, okay.
Oh, that's always fun.
Yeah, they were trying to get rid of sulfuric acid buildup as a result of the tower and the antenna array being located near salt water and located near, smoke stacks from some nearby factory or incinerator. So the combination of gases created sulfuric corrosion on the antenna bays, and they thought the idea would be, well, go up there and spray denatured alcohol or something similar to that on the bays to break down the contaminants. So according to the tower climber I talked to who told me this story, they walked off the job and told them that they're nuts and there's no way you're going to do it while it's transmitting. And the engineering staff apparently had no issue. They were like, what are you talking about? What's wrong? That's not going to happen. He's like, not going to happen. It's a radiating element. All it takes is a simple flash or a static, anything, and poof, you're spraying alcohol in the air.
What they should have done was giving them some hot dogs or something. I mean, hey, weenie roast up on the tower.
Yeah.
Hey, I found what I was looking for.
Oh, good, good. Let's see it.
Okay, well, this is a small piece of transmission line. It came straight up out of the transmitter and had a 90-degree elbow on it. And when we were doing some work at the site, we had accidentally jarred the elbow a couple of times, and the bullet in the center came loose. The bullet is what is called the center conductor. That's what the connector is.
Yeah.
Well, anyway, I'll show you the transmitter side first. This was only about 4 or 5 seconds at 50 kilowatts. That was in the transmitter. If you could see, that's a piece of threaded rod that changes diameter from here to here. It's discolored. This should be a nice bright copper. But the impressive thing is the end that was up near the bullet, or that was up near the 90-degree. Blew a hole right through the thing.
Burned through. Wow.
Yeah. Yeah, and so that was just, it was just, all of a sudden there was a bang, and it was like, what the hell was that? And shut the transmitter down and took a look, and that's it.
Conductor? I was trying to ask Tom if that bullet was actually fused now to the inner conductor. Is that what's happened, or is that bullet made onto the end of that?
Oh, it ain't going nowhere.
Okay, so it's so what you have so that is what I thought it was. That is a standard bullet.
Yep.
Is that 3 1/8 inch size line? Is that what that's for?
That was 3-inch line.
Yeah, 3 inch line.
And what I have here, this is a regular piece, and here's the regular bullet, and here's how it comes out.
Ah, okay, good.
So,
nice demo. Yeah.
Here's how it goes back in. So that other one, I don't think I'm going to move it. It is, it's fused in there.
that bullet is silver plated, and it's very springy. It has fingers. You know, the center. It's made of these fingers that are all slightly too small to go into the end of the pipe, and so you have to really shove it in there, and it makes a lot of good contact area. Finger stock, fingers, I guess you might.
Yeah, it's a springy type of metal, and it fits in. The actual pipe itself is actually a little smaller than it should be to fit this thing in, so it makes a nice snug fit.
Yeah.
And unfortunately, when one side opens up and all of a sudden there's no load on the transmitter, it goes kaboom.
And the big white piece is Teflon to hold it precisely in the middle of the outer conductor.
Right, and when you put two pieces of transmission line, don't forget, this being a coaxial cable, there'd be a piece of, there'd be another copper tube out here, and this will hold it right dead center in the. You usually put a flange, or they have a what's called a coupler, which would be about that long, and that goes around the outside of the outer jacket on the transmission line, and this holds it dead center. And you'll also notice, if you take a look, that there's a hole in the Teflon, that when this thing goes in there, this allows any gas to pass through from one end to the other. So that's how you pressurize the entire transmission line. Even when you have these in the middle.
Is your system pressurized at that point?
No.
Okay.
In the transmitter building, no.
Gotcha.
And we've got foam coax going out to the towers, but I've up at our FM in Hartford, we've got pressurized transmission line going up the tower, and we use a dehydrator.
And oftentimes AM systems are not pressurized. Oftentimes they are a foam dielectric coax. So there's expanded foam between the center conductor and the outer there on the inside. But not always, but usually FM systems do tend to be pressurized. Although I've worked with quite a few that did have foam as well. The problem with foam is if something if there becomes a leak in the system, you don't know about it until it's really too late at that point. Also, if you want to pressurize the antenna, some foam dielectric systems will let you insert gas up the middle of the center conductor, and then that reaches to the antenna and pressurizes the antenna system if it's a pressurizable antenna, which smaller ones may not be, but all medium and larger ones certainly would be.
Yes, and once again, that's to keep the primary reason is to keep the line from condensing. If you keep dry air in there, when you get a temperature differential, like this morning when I got up, it was 65 degrees, and by midday it was almost 100, and then it'll cool down at night. Well, naturally it's going to condense. If the transmission line's full of hot air, you're not going to get that water in there, and putting water in a transmission line like this with 50 kilowatts is not a good thing, because that'll arc right over.
It's funny how if you have a typical FM transmitter site, so FM transmitter in the building, the coax goes out kind of high up, it goes out of the building, and then it goes over to the tower, and there's usually a drip loop at the bottom, right? Sometimes there may even be a single turn to maybe help with some lightning entering the building, but there's usually a drip loop, and then it attaches to the tower and goes on up the tower. Well, it's funny, if water does collect inside the coax because of it perhaps being non-pressurized for too long, it's funny how that water, when it sits in the bottom of the coax and bridges the center conductor of the coax with the outer conductor, it's funny how that water is just about 50 ohms. You ever notice that? Yeah. I've had several, usually small town radio stations would call me, "Hey, we're not getting out very good." And I'd go there and kind of look around. The transmitter's behaving a little bit weird, but the reflected power isn't too bad. And I'd go outside and kind of look around. Then I thought, well, I would touch the coax at the drip loop point, and it was like, wow, it's on fire, it's hot. And the water was actually boiling. inside there at the bottom of the drip loop. Well, you turn the transmitter off, you let things cool down, you take you got to do something. You take an electric drill and you drill the smallest hole you can up in the bottom of the drip loop, and I mean like a racehorse on a flat rock. Water comes water comes out this hole you've just drilled, just because it's hot and it's under some pressure because and finally when it all comes out, now you've got this hole in the coax, but at least you don't have water in there anymore. You turn the transmitter back on there, everything's fine, except you've got to replace some coax or figure out a way to plug that hole back up and then repressurize the system. Usually you run several tanks of nitrogen through there, and just pray for the best. Golly, I had a comment about all that with coax. We have another story about coax, though, I want to jump into. Burke, there's a graphic that I sent you about nanotechnologies being applied to coax. I'm going to go ahead and start telling you about this, and maybe Burke can get this graphic up. With all the research on nanotechnology, we shouldn't be surprised that one of the latest technologies to involve this would be coaxial cables, but on the nanoscale. And the main interest in nanocoaxial cable is as an energy storage device due to the very high capacitance that's available between the inner and the outer conductors. So researchers at Rice University in Texas have created a little teeny tiny coaxial cable that's about 1,000 times smaller than a human hair. The co-author of the study, Jun Liu, said, "We didn't expect to create this when we started. At the outset, we were just curious to see what would happen electrically and mechanically if we took small copper wire known as interconnects and covered them with a thin layer of carbon. The study found that the capacitance of the nano cable is 10 times greater than was predicted with classical electrostatic modeling. The capacitance of the new nano cable is up to 143 microfarads per square centimeter." That sounds like a lot. 143 microfarads is I guess, reasonably significant per square centimeter. So for energy storage, Liu envisioned a large-scale energy storage device consisting of millions of these tiny nano cables side by side in large areas. And we've on some of the other shows on TWiT, they've talked about battery technology, which is really which may turn into basically just big capacitor technology. And this may be an interesting way to get that done using nanotechnology and in the form of little tiny coaxial storage devices. The nanoscale cable might also be used as transmission line for RF signals at the nanoscale, that Liu added. This could be useful as a fundamental building block in micro and nano-sized electromechanical systems like lab-on-a-chip devices. Well, kind of interesting. You guys, Chris Tobin, you got any thought on this kind of nanotechnology and where it might go?
Some of the stuff I've read about nanotechnology is just mind-boggling. It's almost borderline science fiction coming to true life. But no, I haven't. I've read something about what you're talking. I haven't really read deep into it, but it's pretty wild. I mean, a lot of stuff related to nanotechnology is just it's wild. It takes a while to sit down and get your head around it.
It sure does. It sure does. And it's so different from what we deal with day to day in typical broadcasting, where we tend to deal with some big stuff, right? Big honking.
And they're also talking about nanotechnology for solar power gathering with nano wires and stuff. So it's like it's crazy.
One more quick story before we head off to do a quick break and then back to our main subject. Apparently, automakers are putting HD radio into more and more cars. Now, flashback 25 years maybe to the days of AM stereo. One thing I know, I worked for a station in Richmond, Kentucky. It was WEKY, owned by a fellow named Bill Walters. And Bill's reasonable visionary in radio, does a lot of things before everybody else does. WEKY was the third radio station in the state of Kentucky to start transmitting AM stereo. And nobody had a radio to pick it up. I mean, the station had one. I think Bill may have had one. And we transmitted it for several years, and then just got tired of the upkeep and the paying for the stereo STL, and I left the station at some point, and I'm not sure if whoever after me took care of it very well. But then I started noticing that cars started coming with AM stereo radios after some of the early pioneer AM stereo stations had gotten tired of transmitting AM stereo and worrying about the muss and the fuss. Well, I hope that's not going to happen to HD, but maybe it will. Hopefully it won't. 14 new car models from 9 different automotive brands that offer HD radio as standard equipment are starting to hit dealerships right now. There's HD radio in the 2013 Cadillac STS, the 2012 Hyundai Azera, the 2013 Lexus GS, RX, and LX, the 2013 Scion, and the IQ, the 2013 Subaru BRZ. It's an option in the 2013 Ford Escape, Toyota Venza, Porsche Cayenne, and Panamera, and the Porsche 911, if that's your car of choice. Also, the Mazda CX-5 is the first Mazda to offer HD radio as an option for the dash, but it's standard in a whole bunch of cars. Guys, what do you think about it? Tom, what about this HD radio now being in so many new cars? What's your take?
I think it's interesting that it is. The thing that bothers me is it's been around. I mean, WOR was went HD in 2001, so it's been around for 10, 11 years now, and we're just starting to get it in cars. But we also have internet radio now in cars, so there's an awful lot of competition out there.
Yeah.
Well, Pandora. I mean, we've always had. Well, we haven't always had CD players, but as soon as they could put one in a car, they did. Before that, it was cassettes. I just don't know where that's going to go. But taking a look at listening statistics, most radio listening is done in the car. So I think it's a good thing that it's showing up in the cars now. But boy, I hope it's just not too little, too late.
Chris, Tobin, you were involved in a bunch of HD stations.
Yes, I worked with one of the FMs that was the very early adopters, and worked with the HD folks, Ubiquity, and before that. I have to agree with Tom to some extent that we all have been broadcasting HD for a long time. The offerings in HD are very limited. I mean, I'm almost embarrassed to say very limited, and I too agree with it. It could very well be a little too late. I still believe in the best way for the radio industry, and this includes television as well for the visual medium, but for radio, HD is not the way it's going to go. It's not going to be the solution. FM chips and cell phones not the solution. The real solution is really coming down to one simple thing. Why do good books last throughout the centuries? Because of the content that they're written by. Why does good radio last? Because the content is what people want to hear. That's why sports stations on radio do very well. That's why news stations do very well. That's why music stations don't do very well, because, as Tom pointed out, you have Pandora. You have, you got dozens of places to get music. I can find, half my favorite jazz music without even touching the radio dial, even though we have a very good jazz station here in town, and I do listen to them and get a lot of great stuff. Why? Because when the song is over, the person that's talking on the microphone, you may recall we used to call them disc jockeys, or maybe we'll be more modern and say presenters, and they talk about that song. They talk about the artists. They talk about how they came to be, why that music sounds the way it does, and that, my friends, is what makes the difference. So, HD radio, that's all well and good, but you know what? It's more about the content and how you package it, and I think that's where the success will be. If we can get them in the cars, it's great. I mean, it helps to reinforce that radio is still relevant. But the way things are going with internet-delivered technologies, look at the Ford products, Ford motor vehicles, Ford Sync. That is a platform, okay? It's not a car. It's a platform. So where can they go with that? Where does it go? I mean, that's what it's about. And is HD radio taking advantage of that platform? Are we really doing anything? Because of the majority of publicly traded companies that are broadcast companies, they're not interested in doing anything unless they can make a buck real fast. So, the only places that will do it right will be, places like Tom's where it's privately owned. And then there's something going on.
Let me say 2 words about internet radio on the dashboard. Bandwidth cap.
Yeah, so?
HD radio doesn't have a bandwidth cap. Now, I realize the content offerings are not stellar. There are additional offerings, but there's no bandwidth cap. Now, if in the next 2 or 3 years, 50% of the cars on the road have internet dashboards, will the wireless internet providers be able to serve you the data that your modem is asking for?
Sure, you'll pay for it. That's why the models are changing now. That's why the cell phone companies are changing their pay models as we speak. That's why you see the phone bills changing toward more data-related cost changes and voice. They're moving away from voice. Once they can do voice over LTE, VoLTE as it's known, you will see a complete shift take place, and people will pay for it. Yes, there's a bandwidth cap. You're absolutely right. But you know what? HD radio has got limitations as well. Okay? You can either take away your analog channel altogether and go full bandwidth digital, but that's still caps, or you could do a hybrid. That's not the solution. You know, looking at it from that perspective, I get it, but it's not going to stop people. Trust me. I've watched people pay through the nose for stuff because that's what they wanted, regardless of the fact that they paid. And I think the same will be true in the car. I mean, if you're in a car, you know, a good percentage of the day, you're going to pay to make that trip, that time worthwhile. And people are going to do it.
People
will, but I believe that's what's going to happen.
People will go out of their way to get the programming they want. And, you know, back pre-internet, yes, there was a pre-internet. Back pre-internet, and when I was a radio station engineer, I remember I was engineering for an album rock station, and some people just loved it. They were putting up outdoor antennas to pick it up through the urban clutter. It was a rimshot station outside of Memphis. And I got calls. People wanted to know, how do I put up an antenna? How do I pick up your station better? Because they wanted to hear that album rock. Again, pre-internet. It is going to be interesting. I will add something to the conversation by saying that if you – well, the problem is it's not always true. I've heard some stations doing HD, and this would be the HD1, and not dividing the bandwidth up with an HD2 and HD3, but just doing an HD1. I have heard stations that I didn't think sounded so good on their analog, but on their HD1, they were really processing it very sweetly. And I remember a time I was in Memphis back in some of the earlier days of HD, and there was a rap and hip hop station that normally I just wouldn't listen to, and I didn't think it sounded that good on the analog. But I punched in the HD version of that station, and oh my goodness, it sounded good. And I still wasn't excited about the content, but man, the music just really punched, and the high end was pretty. And now they were using, again, all 96 kilobits of their allocation for HD for that one channel. But and people will argue, well, quality in the car isn't that important, and Sirius and XM have kind of proven that out with very low bit rates on channels that I find a little difficult to listen to it at times because the bit rate is so low. Are we past the point of having really good audio quality in the car or transmitting it, or do people just not care about that?
You know, people do notice when it's processed right and when it does sound good and the quality's good. It's funny you're talking about Sirius XM. I mean, I do have an XM radio in the car. Because you listen to talk radio all day. When you go home, it's time to rock and roll. XM I can handle, but my wife's car has Sirius, and I do not like that codec they use. It just drives me out of my mind. I don't like it, and to the point where if I bought another car tomorrow, and I probably would not subscribe to Sirius if it came with Sirius. I'd plug my little XM radio back in and listen to that because I like the codec better. But you're right. If you process the digital audio or the bit reduced audio correctly, it's going to sound really good. But also, there's some other things going on as opposed to the analog audio. You don't have a preemphasis curve on the HD. So and for those listening who don't know what that is, on the transmit side, we goose the high end as much as 15 dB up to 15 kilohertz, and then your radio takes it back down. Now there could be a mismatch in the radio where it's not exactly a 75 microsecond preemphasis curve. There could be some issues going on in the stereo generator. The reason we do this is everybody thinks FM is noise free and quiet, and well, no, it's not. The higher you go with a modulating frequency, it gets noisy. That's why we bring it down on the radio side and goose it on the transmit side. But without that preemphasis curve, you're not limiting the high end. Because let's face it, if you're gonna goose the high end up to 15 dB, you've got to limit that before you limit anything else in the audio. So there's a certain amount of clipping going on in the high end in an analog FM signal. Once you take that away, even through a bit reduced codec, it sounds pretty damn good. Because you don't have, while you may have some artifacts from the codec going on, you don't have any of the skewing of the frequency response, and you don't have any of the clipping. So it sounds much smoother.
It is interesting, the different aberrations that we get with different transmission schemes. We've talked about that before on the show. AM radio actually can sound awfully good, but we have this NRSC mask that we all have to fit in now. And in some ways it was a Band-Aid patch, and in other ways it kind of screwed things up. We have FM radio that we try to get the last bit of loudness out of it. And I got to tell you, the folks at Omni and the folks at Orban have done an amazing job of getting loudness and quality, if it's not abused, through FM. But then we've got codecs, and we can process differently for codecs, but we have a different set of aberrations in codecs, especially when we get down to low bit rates and we're actually reproducing the high end. We're transmitting the high end as kind of a shorthand based on harmonic on fundamentals, and then there's a shorthand that describes the high end to reproduce. So anyway. It is interesting the different aberrations we get. What would be great is someday, when I don't know if this will ever happen, if we can break the laws of physics or bend them even more, but when we have linear audio everywhere, wouldn't that be just wonderful? I know that at trade shows, when I'm demonstrating, say, Axia audio gear, mixers and stuff, if my source material is, even if it's AAC coded at say 128 versus a linear file, I've played, sets of music like through Winamp from either source, and the linear sounds better. You almost got to be in the industry for a while and really know what to listen for. But after your brain kind of picks out what to listen for, it becomes somewhat obvious what to listen for. Any comments on that?
Kirk, Well, not only that, but also I was going to make another comment on some of these car radios. There is a manufacturer, I'm not going to say who it is, and they're notorious for this. They're trying to get you, as the driver in the car, every last bit of signal out of that, or every last bit of mileage out of the signal you're listening to on FM, and they have what's called high blend.
Oh, yeah.
And that drives me nuts, because all of a sudden your audio bandwidth starts doing this, and then it flips into mono, and it still keeps doing this. And next thing you know, the FM sounds like this, and you wonder why it sounds like hell. And people blame the station. Matter of fact, the late Rick Buckley, he used to call me every couple of weeks and drive me nuts, because he'd be listening to our station in Hartford. He'd go out to his weekend home in Long Island, and he'd call me up and say, "What the hell's going on with Hartford? It sounds like crap." I'm like, "You're driving the Cadillac again, aren't you?"
Oh, no. Oh, God.
And he'd go, "Oh, well, yeah." And I'd say, "I've told you 1,000 times, it's high blend." There's nothing wrong with the station,
A few years ago, I spent an evening with the late Sam Phillips, the guy who discovered Elvis and started Sun Records. I spent an evening with Sam Phillips going back and forth between the audio processor in the station and whatever big honking Ford land yacht he was driving at the time. And I thought the speakers in the Ford land yacht were a little muffled sounding, but we adjusted the processing based upon the Ford land yacht he was driving. I mean, this was a long time ago. It might have been a 1987 or 89 Ford something or other, but it was a big honking car, the kind that just kind of floats down the road like that. Well, we got done setting the processing. I'm thinking, I don't know if this is going to turn out well. Well, I got in my car. Of course, we hadn't been in my car the whole evening. We got in my car, and it was just so shrill. Oh, my goodness. You got to be careful when you're dealing with sound and audio processing, and make sure that your monitoring system is typical, or make sure it's known to your head and your ears and your psychoacoustic model inside your head. Hey, guys, we got to break a second and talk about our sponsor. When we come back from the break, we're going to have to finish up with the subject of summertime engineering and how that goes. Also, you may want to consider, right after the break, you may want to think about if you had to build a brand new 50 kilowatt AM transmitter site, not that you probably would these days, but if you had to, how small of a building could you fit it into? We'll talk about that. All right, let's talk about our sponsor, which is the Telos Alliance. Now, you guys may know that I work for the folks at Telos. I'm the VP of Telos Products. The Telos Alliance consists of 4 companies all working together. Well, sometimes we work together. Sometimes we do a little competition. There's Telos, the company that Steve Church started almost 30 years ago. There's Omnia, the company that Frank Foti started and brought into the fold, merged with Steve's Telos company. There's Axia, which is a newcomer, came along in the early part of the 2000 decade, about 2002 or so, invented the LiveWire, a way of getting linear audio around unbuffered in basically real time across an Ethernet network. And there's Linear Acoustic, a company that the rest of the Telos companies merged with about 4 years ago or so, Tim Carroll and Christina Carroll, and their wonderful company that does audio processing for television. Together, these companies are really setting incredible standards and bringing broadcasters equipment that is meaningful, useful, helps them create wonderful content. If you have a chance, I would ask you to go to the telosalliance.com website that Burke was just showing there. You can sign up to get the Telos Alliance catalog. And it's not just a catalog showing products. There's plenty of articles in there, too. There's a couple articles that I wrote, some that Joe Talbot has written, an article by Denny Sanders, who was just a terrific program director back in the Buzzard WMMS days. Also, Frank Foti has written an article in there, and Corny Gould. You'll also find an article by Milos Nemchik in the Axia section of the catalog, and an article, I believe, either Leif or maybe Tim Carroll's written an article in the linear acoustic section of the catalog. Really good articles that are leading edge technology, things that engineers today really ought to be up on and ought to know about the technologies, where things are going, and how we're getting things done in the merging world of audio, video, and IP. So I would ask you to go sign up for the catalog. You can download it. Just fill out the information there. You have an opportunity to download the PDF. You can put it on your cell phone. You can put it on your iPad or your Android tablet, on your laptop. And we'll send you a nice coffee table catalog. It's a beautiful glossy catalog from the Telos Alliance. Check it out if you would. There's also a blog page where we put some articles. I think a white paper I did for NAB is going to be posted there pretty shortly. Other white papers that we presented at NAB are also posted there in the blog section. And, of course, access to each of the 4 brands and their individual offerings. Check it out, please. telosalliance.com. And I would appreciate it very much if you would go there and check it out. All right, gentlemen, back to the This Week in Radio Tech Show, number 134. I'm talking with 2 of our regular co-hosts. First of all, Chris Tobin, the best-dressed engineer in radio in Manhattan, New York. There he is right there. He's taking a quick break. And then Tom Ray. Is Tom there? Is Tom in his ham shack, or is he left too? Hello.
No, I'm sitting here and, just taking up space. That's what I do best.
So Tom, you take care of and you built this 50 kilowatt WOR transmitter site. If you were asked to build a 50 kilowatt transmitter site, I'm just curious, how small a building could you put it in? Now, forget redundancy. If you just had one
transmitter or 2?
One transmitter.
How many towers?
One tower.
Okay, single tower, 1 transmitter. You could probably put that into a 15 by 15 building.
Yeah.
Not counting the generator. The transmitter itself is about 10 feet long by about 4 feet wide by about 6 feet high, 6.5 feet high. And you wouldn't need a phaser because you've only got one tower. Wouldn't need a place to put the generator, so because we're talking no redundancy, you'd probably have one equipment rack, which would have your STL equipment, whether it's fiber, whether it's an intraplex, whether it's microwave, whatever it is, and the audio processing and the remote control system, and you're done.
Wow. Okay. All right. And I was just thinking about, you have a Harris transmitter. What? Probably the Harris DX.
The Harris 3DX50. I've got two of them, main and back.
How much heat do those guys make?
At full power, about 14,000 watts is what they throw off. It sounds like a lot, but that's actually
that's 10 hair dryers.
Yeah, well, it's 10 hair dryers, but it's actually about 90% to 92% efficient AC to RF, so that's pretty good. A tube transmitter will throw off a heck of a lot more than that because you're talking probably around 50, maybe 60% efficiency. So, you could theoretically be getting 50 kilowatts thrown back into the room. So this thing here, in the summertime, the air conditioning runs, but it doesn't run all that often. Today was a very hot day in New York, and I can guarantee if I went out there, air conditioning would have come on, shut off for about 10 minutes, come back on, go off for about 10 minutes. In the winter, it actually keeps the building fairly warm. 14 kilowatts is not too bad, plus the building's air conditioned fairly well. And now we're running the MDCL, so it's a little more efficient than it was before.
I was actually going to ask you about that. The MDCL, we've talked about it on previous shows. Remind us of what that acronym stands for.
A modulation-dependent carrier level, and what that means is that we take the actual level of the RF carrier, and when we modulate hard, the carrier drops because the carrier really doesn't do a heck of a lot, and it's not really required for transmission purposes. It's kind of a throwback to the first days of AM radio, and older radios. Yeah, they do utilize the carrier somewhat, but most modern radios with a modern detector, it couldn't care less if the carrier were there or not. It just demodulates a signal. That's it.
Hey, we got one more subject to cover, and I want to get it covered before we sign off, and that is about summertime engineering, and how is it different than what you're doing in the fall and in the winter and in the spring. First of all, it's hot as blazes. I take care of some radio stations that I'm part owner of in Mississippi, where it's hot and humid, and thunderstorms, and we had some straight line winds a couple weeks ago that were just incredible. Actually tore the coax off one of our towers.
Wow.
Yeah. Well, the coax may not have been on that great anyway, but it certainly whipped that coax around and yanked it out of the bottom of the antenna. I think it's a 4-bay, maybe it's a 6-bay. I think a 4-bay FM antenna. It's engine 5/8 air dielectric coax, ripped it off the tower and slung it over the STL antenna that's about halfway up the tower. So we got a crew coming to take care of that. And in American Samoa, where it's always summer, what do you do for summertime engineering? Tom, will ask you first, and then we'll hit Chris with that question.
Well, you're right about the humidity, Kirk. I mean, most people think WOR. I mean, we're in New York City, but the transmitter's over in Jersey, in the Jersey Meadowlands. Now, it's only 6 miles from Manhattan, but it's a swamp. It's a literal swamp. And flood level there, 100-year flood level is 9 feet. The transmitter building's at about 13.5, as are the tower bases, as are the guy anchors. But every now and then, we had we had a sample line go bad. Long story on that, but to replace that, we actually had to go out walking through the swamp. And let me tell you, when you come down just that 12 feet, the humidity goes from 90% to 190%. So, when you're out there, if you've got an AM facility, what you want to do in the summertime, around the base of the tower, what they normally do is they put down it looks like chicken wire. It's a copper mesh, and that's the first part of your ground system. Around the tower especially, you want to take a look, and you want to keep as much growth out of there as possible, whether that means you spread something like Roundup. Definitely, if you got a little tree that starts poking up, you got to get it out of there because that will rip apart your ground screen. Same thing out in the field. If you've got any little trees starting, you really need to pull them up so they don't rip your ground system up. But if you're going to be out there working, keep 1 or 2 bottles of water close at hand. Watch out for wasps and bees. They like to inhabit tuning houses. So you open.
Oh my goodness, that's true. Yeah.
Yeah, I usually open a tuning house door. I stand behind the door and open it and see if anything flies out. And that actually becomes a big problem with a satellite dish. So if you've got a satellite dish on site and you're in an area that where the bees start coming out and just little bugs in general, you want to cover the feed horn. So you've got the dish, and you've got at the other end you've got the feed horn where the LNB is located. They do make little covers. Now, if you don't have a little cover, get a coffee can cover and either duct tape it or use black electrical tape, and that will work because black electrical tape is somewhat transparent to the RF. It's not a problem, but you want to keep the bees out of there because there's nothing worse than bee fade, because you usually have to wait until after
That's right.
Yeah, you have to wait until after dark to get out there with your spray. So
you want to spray them when they're all home and docile.
Yes, you don't want to be spraying in the middle of the day because you'll be running. And if you got a swamp out there, you ain't running too fast.
I've done the spray and run. I've done the let's go have some dinner, come back about 9:30 and give those guys a surprise. Yeah, I used to call it wasp fade, but yeah, and a paper wasp dry nest is fairly transparent to microwave frequencies, right? But when those bodies all come back to roost,
the microwave frequencies go away in a big hurry.
Yeah. Yeah. So take that to heart, radio engineers. If your satellite delivered programming disappears every evening just after sunset, it ain't sun fade. It's wasp fade. All right. Hey, Chris Tobin, you got some summertime engineering hints for us.
Summertime engineering hints, yes. First thing, let's see, transmitter facilities, do this. Check the grills on your air conditioning systems. Have it blown out, sprayed out so that they're not clogged from any, pollen that may be happening. Like Tom's site and the site I used to maintain in the Meadowlands, in the New Jersey swamplands, the Aphrodites, not Aphrodite, what do they call it? Aphrodites or whatever that plant is, the cattails. Phragmites, thank you. Yeah, I got it all wrong. The pollen, that stuff that would get into the air conditioning grills was unbelievable. It would destroy everything. So clean them out.
And if you're sucking air into the building, boy, you got to clean those filters. Oh, my God.
Yeah, exactly. Clean your transmitter filters, air exchange filters. Check your generator. Make sure the fluids are topped off. Make sure the generator seals, hoses are not looking fat, or it looks like they're starting to decay. Hot weather definitely makes them go faster. So check those those levels on that stuff. Same thing with the radiator grill on that. Make sure it's clean and cleared. Also at the base of your transmitter towers, just as Tom pointed out, check around, check your cable connections, make sure everything appears to be normal. Do your best for that. What else is there for the summertime stuff? Those are the biggies that you have to watch out for. And make sure you have plenty of water available at the transmitter building. So keep that in the fridge or keep it in a closet. If you keep it sealed, if it's room temperature, it's fine. Remember, your body core temperature, you don't want to suddenly hit with 60-degree cold water. That's actually not healthy for you. So if you're working outdoors and you have to hydrate yourself, room temperature water is actually better than freezing cold water to hit your body core.
What about beer? Should that be cold or room temperature?
Beer should be cold and consumed while sitting down watching the spoils of your work being completed.
Okay. Yes. And, somebody in the chat room just mentioned birds. Keep an eye out for birds at the site. We get these, I think they're sparrows at the WR transmitter site, and I can usually tell where the nest is because these birds literally dive bomb me.
I've
had my hat knocked off my head.
Goodness.
And one year we had a condor that built a nest on top of the telephone pole right outside the building. And he left everybody alone, or actually she left everybody alone. I say she because all of a sudden there were little condors up in the nest. But she was feeding them. And there's nothing quite like showing up first thing in the morning and seeing fish heads all over the ground, all over near where that pole is.
We're going to have to come back on a later show when we get restarted in the fall and talk about what's the strangest thing you've come upon at the transmitter site. I think I mentioned one of those myself. It was a car with naked people in it, but we'll that's for another show. Hey, I want to thank our sponsor, which has been my employer, the Telos Alliance, at telosalliance.com. From there, you can sign up for the beautiful Now 2012 catalog, and I sure wish that you would. Thank you very much if you would. Hey, and as you've heard, this is our last episode on the TWiT.tv network. I'm just delightfully thankful to Leo and his team for giving me the encouragement and the vision that, hey, you can do this. You can, if you want to do a podcast, you sure can. And I tell a little bit of story about how this happened, how it came to be, and that's on the website for this show. I wish you'd bookmark it, have a look there, and read the latest entry. The website is thisweekinradiotech.com. That's a lot to type in, but do it once, bookmark it, and you'll be there. thisweekinradiotech.com. And that'll be, of course, all of our old shows are linked from there. So you can go to that site. And now that's the TWiT version of our site. And that's where I've been directing people since we've been on the TWiT network. That's at twit.tv/twirt. But there's also thisweekinradiotech.com. Bookmark that, and that'll keep you up to date on where we're moving to, where we'll be appearing with more shows from This Week in Radio Tech. There's also a plan afoot to take all of the episodes and put them on a YouTube channel. We don't have anything populated there yet, but TWiT Show is a YouTube channel, so we will also have that, and all the episodes will be available there for you. Let me also suggest, if you're a fan of this show, and I thank you so much if you are and for following us, but if you would add to your Twitter at TWiT Show, TWiRT SHOW, at TWiT Show. And hey, we won't spam you with all kinds of stuff. We're just going to let you know where we are going to be for future podcasts. And I wish that you would follow us at TWiT Show. So that would be just great. We're going to take a few months off, and this is great because I'm traveling a bunch this summer. I'm going to Asia twice and going to American Samoa. I'm going to take plenty of video and pictures, especially in American Samoa. I'll be installing a couple of Axia audio consoles at my radio stations there, and I'll come back with some great video and pictures on our subsequent podcasts. So, hey, Tom and Chris, you guys get a few weeks off as well. You won't have this Wednesday night thing to show up at.
And we don't have to put up with you.
That's true. Oh, I hadn't even thought of that, but it should have occurred to me right away.
But, you know, Kirk, it's been a lot of fun. I look forward to the startup and everybody who actually started out with us with just audio and followed us over to the TWiT network. We thank you all for watching and for listening and for participating. You know, it's a nice feeling to know that at least somebody's listening, and we appreciate what Leo's done for us and with the TWiT network. And, you know, they're just so people know there are no hard feelings here. I mean, this is the business we're in, and it happens. So, you know, we'll pop up again when the fall starts.
All right,
and we'll all be raring to go because we'll get a nice break.
Chris, I think your wife will get to see you on Wednesday nights for a while.
Well, she gets to see me now. She just watches in the audience. I have my one-person audience here, which is fun. And I have to thank everyone, and I appreciate what we've all gone through and enjoyed, and the folks have emailed. And I got to make sure I say hello and thank you very much for your support. Those folks from Bell Media in Canada, they know who they are, and I won't be tossing any codecs around at the next CCBE show. Another Inside Baseball. But for those who have watched and followed, they know who they are, and they'll enjoy a good chuckle when they watch or listen to this episode. And also to a couple of folks at Nortel Transmitters who I bumped into recently at a couple of SBE meetings who enjoy our show. So I want to make sure I give them some credit for participating in the audience. So we have a few of those folks. So I am looking forward to September. I think we're going to have a great time, and you know, the hiatus for the summer will be good for everyone.
And we'll let you know where we pop up. And hey, audience, don't give Leo any trouble over this. There was some of these parts of these decisions have been beyond Leo's control. So I appreciate Leo personally and professionally very, very much. And I think I'm occasionally going to be back on the TWiT network doing a thing or two here and there, maybe a little reporting, maybe a little guesting here and there. So if you're a TWiT network fan, continue to be. And I'll see you occasionally on the TWiT network. So also a huge thanks to Burke, who has been our producer for so long. Burke, thank you so much for putting up with us and hitting all the buttons and knobs and making us look somewhat professional. That's amazing for three radio guys. You're welcome to say hi, Bert.
That's okay. You can talk.
All right, let's wrap it.
Welcome. I don't think Burke loves us anymore.
Yes, he's left the building.
All right, guys, we
just
will wrap it up.
remember one thing.
Yep.
Remember one thing. Leo said 7 years ago, this is the way things were going in the future, and here we are today. Just remember that.
That's right.
He's a genius.
All right. Hey, and on behalf of Chris Tarr, I know he loves doing the show too. He and I were on the show last week, so Chris got plenty of say-so last week. He is off giving a paper, I believe, on this date, so he couldn't make it on the show. Tom Ray and Chris Tobin, love you guys. Appreciate you very much, and we're going to get together back in the fall on some other network.
You
Absolutely.
bet. It'll be organized mayhem.
That's right. Maybe we should call the show that. So thanks again to Telos Alliance at telosalliance.com for sponsoring the show. And we will see you another time on This Week in Radio Tech. Be sure you follow us at torchshow.com on Twitter. And you can check out our Facebook page, too. We'll see you there, too. Take care, everybody. Bye-bye.
So long.